In this video, you will learn how to determine various attributes of an array. Earlier in the tutorial, we created a one-dimensional array with the depth at breast height data, another one-dimensional array with the trees per acre data, and a two-dimensional array with both sets of data, which we called tree data. If you do not have these arrays, please take a moment to recreate them. Now, if you notice in the workspace, we can see the names of each of the variables for each array. And for the one-dimensional arrays, we see the first few entries in each array. But for the two-dimensional array, we only see the size of the array in the value column. So we see that it has 2 rows and 10 columns. Additionally, we see the minimum value in each array and the maximum value in each array. And you should note that for any two-dimensional array, it's the minimum and maximum over all values within the array, not just over one particular row or column. So we can also include other information in the workspace. So for example, if I right-click on this bar up here, I can select any of these various attributes. So I can do the range, the mean, the median, the mode, the variance, the standard deviation. I can also choose the size of the array, the bytes, that's the amount of memory the array takes up, and the class. But for now, we're going to ignore bytes and class and just focus on all the others. So for example, let me select median value. So you can see another column is created in the workspace, and it shows me the median value of each of my data sets. I could also select the size. If I look at the size, I can see that my one-dimensional arrays each have 1 row and 10 columns, and my two-dimensional array has 2 rows and 10 columns. So I can also deselect or remove any of these columns. So for example, I could remove the value column. So I can add or subtract any of these attributes that I want to look at. I can also switch them around, switch the columns to whatever order I would like. Now, the size tells us how big each array is. However, I don't necessarily need to look into the workspace to determine how big an array is. I also have built-in functions within Matlab that can tell me how big an array is. So for example, for a one-dimensional array, we can use the length function to find the total number of entries in an array. So for example, I could take the length of the dbh array. So notice the dbh is in parentheses, and the answer is 10. So that's telling me that there are 10 entries in the one-dimensional dbh array. If I try and use the length command on a two-dimensional array, what I will get is the larger of the two values of the number of rows or the number of columns. So in the case of tree data, the number of columns is larger than the number of rows. So there are 10 columns and 2 rows. So the length function returns the value 10. Now, if I want to know both the number of rows and the number of columns in an array, instead of using length, I can use the function size. So if I take the size of tree data, I get 2 and 10. So this is telling me that there are 2 rows and 10 columns. And if I took the size of the dbh array, it tells me that there's 1 row and 10 columns. So far, when we have entered one-dimensional arrays into Matlab, we have only had 1 row with some number of columns. But this isn't the only way that we can have a one-dimensional array. We can also have one-dimensional arrays that have many rows but just 1 column. And I can turn an array with 1 row into an array with 1 column by transposing it using an apostrophe. So, for example, let's transpose the dbh data. So I'm going to save this as something else. I'm going to save it as dbh column, so underscore there. So dbh column is going to be the transpose of our original dbh data. So I'm going to have dbh with an apostrophe or a tick mark after it. And if I press enter, now I see the dbh data listed in a column instead of in a row. And if I take the size of dbh column, I can see that there are 10 rows and 1 column. In addition to being able to determine attributes like max and min over in the workspace, I can also use built-in functions to determine those values. So for example, I can take the max of the dbh vector to find the maximum. I can take the min of the dbh vector to find the minimum. And likewise, I have similar functions for median, mode, etc. So median is median, dbh, mode is mode, and what else did we have over here? We had variance and standard deviation. So for standard deviation, it's std is the function. So we take std of dbh, so that is the standard deviation. And then we also have variance. Variance function is var. So var of dbh, and that's the value of the variance. So to recap, you now know how to determine many attributes of an array, such as the size, the length, the value of the maximum, minimum, mean, median, mode, standard deviation, and variance values. And you can determine these values either through built-in MATLAB functions in the command window or through looking at the workspace.